Hello, good morning, and a warm welcome to all. Thank you for joining this webinar on Embedding Quality Engineering in DevOps Pipeline, which is jointly conducted by Aspire Systems and Source Labs. I'm Maria, your host for today. Let me now introduce the speakers. We have Clinton Sprague. He's the Product Marketing Director for Mobile at Source Labs. Previously, he was a Senior Product Marketing Manager for HP Enterprise Functional Testing. He was also the Director of Product Strategy for the Bolland Solutions Division of Micro Focus, where he created Bolland's mobile strategy for functional test automation. He was also served as the Senior Technical Sales Engineer and Senior Product Marketing Manager for the SIF testing solutions at Bolland Software and Segu Software. We also have Jayanti Jayaraman. She is a seasoned test automation consultant with 14+ years of experience in handling delivery, R&D, and project management in test automation. She has worked with multiple tools and test automation frameworks. She currently manages the continuous testing and tools in Aspire. Now let me quickly brief you on what Aspire and Source Labs do. Aspire Systems is a global technology services firm with expertise in enterprise solutions, digital services, software engineering, testing, and infrastructure services. Aspire works with independent software vendors and some of the world's most innovative enterprises in retail, BFSI, and education verticals. The company currently has over 2,600 employees and 150+ customers globally and is CMMI Level 3 certified. Aspire also has a growing presence in the US, UK, India, Middle East, APAC, and Europe. Source Labs, founded in 2008, is a provider of the world's largest continuous testing cloud for web and mobile applications. Its co-founder, Jason Huggins, invented Selenium and co-developed Appium. Source Labs ensures the world's leading apps and websites work flawlessly on every browser, OS, and device. Its award-winning continuous testing cloud provides development and quality teams with instant access to the test coverage, scalability, and analytics. The company has 200+ employees and 3,000+ active customers who run 2 million tests every day on Source Labs platform. Recently, Aspire and Source Labs have entered into a partnership to help organizations accelerate the transition from manual testing to continuous testing. The continuous testing cloud service from Source Labs and Aspire's DevOps and automation expertise together help organizations implement comprehensive test automation strategies. Aspire's homegrown integration test automation solution, AFTA, can integrate seamlessly with Source Labs and significantly reduce test automation efforts and increase the speed at which they deliver applications. We are glad this partnership has enabled our customers to move their test automation on cloud and also meet the ever-growing challenge of multi-platform, multi-device testing. In today's session, we'll be covering the following topics: importance of quality engineering in DevOps, different dimensions of quality engineering, tools for continuous testing, how continuous testing can make or break a DevOps environment, and implementing continuous testing in a DevOps environment within use case. Now, before we dive into the details, there are a few instructions I would like to share. During the session, if you have any questions, please type them in the question tab located at the bottom, and we'll provide answers during the Q&A session, which will happen towards the end of the webinar. In case we run out of time and are not able to provide answers to your questions today, we'll get back to you via email. Thank you once again for joining the webinar and enjoy the session. Over to you, Clint.
Thank you. So again, my name is Clint Sprague, and I would like to, first I want to tell you about, just talk about how software development has changed over the years. If you've worked with any type of application, whether it was, back in the day when it was client server or even just desktop applications. What we've seen with the advent of Agile and DevOps, that you're seeing new processes and tools are really pushing faster or driving faster releases for organizations. So if we look at the area where it talks about apps, some of you may work with some applications that are desktop or packaged apps. If you think about Workday or SAP or Oracle applications, these are those thick client applications. So you've seen a transition or a combination of teams having to test those as well as desktop web and responsive web applications, as well as just native web apps and mobile apps as well. So the speed of how those applications over the years, speed of releases of those applications over the years have actually changed and actually progressed. So you went from annually to quarterly to actually monthly, and then really started picking up steam where we're able to do it weekly, and then of course daily, and now we're getting to a point of those releases can be on demand as well. And we've also seen the evolution of various software processes, from waterfall, or also what we've termed as fast waterfall, which is really kind of a combination of those that are making that transition into agile development, but they still have some of the aspects of waterfall development. So they're releasing quicker, but their processes still has kind of the aspects in both worlds. And then, of course, you go to continuous integration as well as continuous delivery, which is the heart of DevOps. And part of that, of course, is continuous testing. And if we look at the tools that are actually used to help us do this, we went from proprietary single stack on-premise tools that were kind of based heavily on like the annual license and maintenance fees to solutions that are best of breed, cloud-based, and open source. So in order to make sure that organizations keep up with the pace of development, the tools and the process have had to evolve as well. Now let's look at some of the transformational changes in quality. Now we have legacy testing and continuous testing. When I talk about legacy testing, I'm really talking about how testing is currently done when we talk about those siloed or those isolated solutions, or those desktop solutions, proprietary solutions most of all, and how that has evolved into allowing teams to do continuous testing and the requirements for that. So if we look at some of the things that are done in a legacy testing environment, typically they have a single team that runs the test, or maybe a single QA organization that is responsible for that. And they typically test at one stage at the end of the dev process. You probably heard the term of just throwing it over the wall. So think of that as how testing used to be. The apps would only work in a few specific environments as well. And then it would also run a few long tests and run them infrequently, because it was based upon whatever the results of that build and when they could actually receive that build. With continuous testing, it's actually helped evolve this practice. With continuous testing, of course, you have many teams that run tests, and they test at many stages throughout the development process. And their apps work across different platforms, whether it's your mobile platform, from mobile devices to different OS versions and different browser versions as well. It's also, with continuous testing, you're running many short tests very frequently. And then it's also using a lot of free and open source frameworks. So what you've seen is the growth of open source and having that embedded not only with the development process, but within the testing process as well. So what are some of the requirements for this transformation? Well, you definitely need training and access for distributed teams. And you need to have visibility across the team. So if you think about with legacy testing, you had these various quality reports. With continuous testing, that requirement changes into having a dashboard of analytics that you can get real-time analytics to really understand, and also getting to a point of predictive analytics as you start to integrate artificial intelligence and machine learning as well. Also, we look at speed and reliability, which is definitely paramount to any type of testing within DevOps. And then, of course, comprehensive web, mobile coverage, and functional testing coverage for the types of apps that you're testing. Another key aspect of this is parallel testing, and we'll talk more about that later on in the presentation. And then, of course, all of this requires that there is extensive training across the board for QA organizations and development teams that are actually implementing DevOps. So the need for quality engineering. So quality engineering is a very interesting topic, meaning that if you think about the evolution of QA, we've gone from thinking of quality as just a typical job that just only testers do. And we've expanded this into, when we're looking at quality engineering, it's actually really expanding us into the different areas. So really treating quality as a discipline more than a single task. So what you're seeing here is, when we talk about the different types of the areas of quality engineering and why we need it, it involves key areas. One is, of course, functional and non-functional testing for the user experience. So you want to make sure that it's always tested and certified before it's actually released into production. And then you actually take a more strategic approach for test automation. And this allows you to ensure automation whenever possible. Hence, when we talk about doing continuous testing throughout. So you're looking at it in all different aspects of quality, from functional to performance to security to API, web services, and so forth. And of course, it also has a shift left approach. And when we start talking about a shift left approach, that means you want to start testing earlier in the software development lifecycle as early as possible. And you want to do this whether you're implementing DevOps, but you definitely want to do it when you're implementing any type of agile development as well, using such techniques as behavior-driven development or test-driven development as well. So how do we shift left from quality assurance to quality engineering? When we're looking at taking that shift left approach, we're actually taking we have a different paradigm, so it's a different mindset in terms of how we view that. So what it means is that you're going to have more testing on the development side as well. So a lot of the task and a lot of the testing is going to be shifted left, and that takes you even to the actual user story and requirements phase to ensure. And the reason we do this is because there have been a lot of studies that have said that the later that you find a defect in production, it's going to more to actually correct that particular issue. All right, good. So let's look at the different dimensions of quality engineering. Well, first of all, there's three dimensions, as we talked about earlier, with functional tools and process and non-functional testing. So when we look at this and the various facets of quality engineering, it really encompasses several areas. And as we talked about earlier, there are different platforms in which these applications are released. Before, about, let's say, even 5 years ago, it was either mobile development, or you had web, or you had one of each. But now with responsive design and hybrid web apps, you must include mobile. So mobile is really actually a part of the statement. It's not something that you have to actually add. It's actually a requirement for most organizations. So when we look at this in terms of the type of testing that we need to do, we need to include mobile testing, mobile device testing, resolution testing or visual testing, API automation, test data management, and of course the application. You also want to be able to scale your testing, which is one of the reasons you want to implement cloud-based test automation as well. And this includes using various test automation frameworks. And this will span from using frameworks such as, and there are a ton, but if you think about just the more popular ones, such as Selenium, and then on the mobile side, Appium, as well as Espresso and XUI test. And then, of course, those processes include continuous integration and continuous delivery. Some of the non-functional testing areas that many organizations really struggle with in terms of how can they add this to their overall QE processes is not only performance, but back-end performance, but also front-end performance testing, as well as security, and the ability to do all of these different types of testing on these multiple platforms. So if we look at cloud-based test automation, what it does, it really helps organizations It gives them the ability to worry less about the infrastructure and the ability to scale their testing across these different areas. So instead of having your own internal lab or data center, having a cloud-based solution allows you to really provision the infrastructure specifically to how you're going to test. Whether you're doing headless testing using containers or whether you're doing cross-browser testing, having a cloud-based solution is really much more cost-effective for many organizations, especially even some of the smaller organizations that need to be able to test. And it's going to help manage those features and trigger the appropriate action items across all of these different areas. It's also going to help build pipelines that span across various functions of development. So the goal for cloud-based test automation is to really simplify how you're able to implement continuous integration and continuous delivery within your organization. Now let's look at some of the tools for continuous testing. So
thank you. I'm back.
Okay, great. I will pass it back to you.
Thank you.
No problem.
Here you go with a complete representation of the tools, different types of tools used for different types of testing in the process of continuous testing. So ranging from a web UI testing like functional or regression, and then spanning across different types of testing like usability, performance, mobile automation, security, and then further integration with continuous integration systems, and then API, and then we further talk about a kind of robust cloud-based testing infrastructure like Sauce Labs, wherein the test automation solution and the test automation framework can actually integrate with and be able to trigger parallel test so that we get the complete execution of the regression test get completed, or the automated test cases are completed in parallel. It's achieved through some cloud integration like Sauce Labs. So you see a set of tools like Selenium, UFT, Test Complete, Silk Test, Coded UI for functional testing, and for different tools for usability. And again, in the security or vulnerability checks, we predominantly work with ZAP, Veracode, Fortify, and QA Inspect. And it has a further capability to just link with continuous integration, through which the continuous testing actually gets accomplished by using Jenkins, Bamboo, VSTS, and TFS. And moving on, the next gen testing, like any kind of portal, whether when it gets ported to a mobile app or in the form of a native app or a hybrid app, wherein we work with solutions like APM and Sauce Labs for mobile test automation, device anywhere, test complete. So this is all about a whole sum of tools, the set of tools involved as such in the process of continuous testing. We just move on to the next topic, which is the importance of continuous testing in a DevOps cycle. So this plays a key role in terms of deciding how continuous testing can actually make or break a DevOps environment. The DevOps process could be complete, but how successful it is primarily determined by the continuous testing, which plays a key decision-making role by giving a certification or giving us an assurance of what is the percentage of application which is stable, fit, and ready to be released to the production for further rounds for the real-time usage. So as you see here, it's like in the process of continuous testing, we test early, we get engaged early in the terms of an application lifecycle instead of waiting for a stable code base to get started with the testing process as such. And also we just do a repeatability or kind of a repetitive execution, which is humanly impossible for on-demand testing. When I have to do patches or when I have to do builds frequently, like 4-5 times a day, and working with teams which are geographically distributed across the globe, it becomes a huge challenge for everybody to go pick up a piece and work in cohesion with each other. So here is where continuous testing gives us a great interface or a helping hand in terms of just coordinating with multiple stakeholders, multiple technical functional teams involved here, and really giving them a level of confidence of whatever has been introduced new, the existing is not impacted, as well as portion of whatever is developed is working fine. So it's like two different things from the development and operations perspective of it, how this cycle of build, test, code, plan goes in a cyclic manner,
and how do we just further release them to production, and how do we monitor is how is completely depicted in terms of this accomplishing a complete testing in a DevOps environment. So talking about the success factor of how we do it is the representation we see here. Like, it's the process of continuous integration and continuous delivery, which is typically represented in a DevOps cycle. But there is a sandwich layer which is called the continuous testing, which enables both the processes to gel with each other in a sturdy manner, and then their releases are just going through smooth. So when we talk about continuous delivery, we have challenges of frequent code check-ins, and then code being compiled by people, multiple teams, multiple geographies, and really somebody doesn't have a control of who is doing what, and we just can't lay out a kind of practice wherein check-ins happen only in a particular period of time. And so that the productivity, the development productivity and actual number of functionalities being added on a day-to-day basis is increasing rapidly to meet the speed of the market. So here is where continuous testing helps us to identify what are all possibilities for test automation and how quickly we can get inside through a shift-left approach and then automate it. Say, for example, if the web interface is not ready, then what is the next workaround? Is like we start automating the API calls of the particular application, so that we get feedback continuously, and then we also be able to detect defects at an early stage in the life cycle. So the number of defects which get issues and defects which get passed on to the subsequent stages in an application life cycle, it gets minimized through this process of continuous testing. And also when you get a chance to automate it, it's like triggering the test in terms of parallel threads across machines, across browsers, and we get a chance to cover as many user platforms as possible.
So as Janthi was saying, continuous delivery, continuous integration, and continuous testing, these are all integral parts of DevOps. And you'll need this for quality engineering in these key areas. And I actually heard one of the thought leaders from a company called CloudBees who actually said this: you can't do continuous testing, you can't do continuous delivery or continuous integration without continuous testing. It's embedded within the process. It's all part of the DevOps methodology. So all these items are active. Now, when we look at continuous testing best practices, now some of the CD best practices that you'll see here is some of the things that you may or may not be familiar with. One is, of course, is like automated deployment. And of course, what everyone is probably most familiar with in this is having a central code repository, whether that's using your own proprietary code repository or using something like one of the more popular repositories like GitHub as a repository. And then having a replication of your production environment. So some people have stage environments, some people have where they reproduce it, but they may not be able to reproduce it 100%. And that's one of the key advantages of using the cloud to be able to implement DevOps, because you can spin up actual environments that mimic the actual production environment and allow you to test against something that's actually real. It also allows you to, some of the best practices, code should be pushed and built on a CI server. And then, of course, automated unit and integration test. Years ago, unit tests were actually optional for developers, but now this is kind of a key option in terms, or a key component of how software is tested, as we talked about shifting left testing earlier in the software development lifecycle. So it goes not only at the unit testing level, but the API and web services level as well. Now let's talk about implementing continuous testing in a DevOps environment use case. For this particular one, I want to talk about 4 types of actual testing in the DevOps pipeline. And as we talked about before, continuous testing, it definitely requires a comprehensive solution so that you can test across all of these key areas in the software development lifecycle. So when we talk about the 4 types, we're talking really about the 4 key areas of development, integration, pre-release, and actual feedback. And with each of these different areas, you have different approaches, but also goals. Now, if we look at it from a development perspective, the goal for development is really fast feedback. Again, what can I What issues are we having before we even push this out to an integration perspective? What are we finding out? So the way this is done, that approach for developers is creating small tests with a few isolated platforms. And then when we get to integration testing, the goal is, of course, is to have a stable build. And for a stable build, you want that end-to-end testing for a few integrated platforms. You want to make sure that what you're putting out is actually working. And then, of course, you want that pre-release. You want to make sure it's deployment ready. And with this, that approach is going to be having a full suite of tests for all your platforms so you can run them in parallel. And the goal of parallel execution is basically for speed, and also to make sure that you're getting as much coverage as possible for the application under test. And then, of course, feedback, which is continuous feedback through monitoring and debugging. And this is also monitoring in production, monitoring in pre-release, and all these other areas. And with this, you want to be able, the approach you want to take is actually monitoring those business critical tests and those relevant platforms that are targeted. So if you know, based upon the demographics or the regions of your users, what areas you need to test, what's critical, what could possibly really destroy revenue for your company, you want to make sure that you're testing those critical areas regardless. So if we look at this, how do you implement this with a cloud-based solution like a Soft Labs? Well, if you look at it from the development phase, we're going to test on every pull request. And then, of course, with integration, we want to automate those tests in parallel. Again, we want to be able to get as much coverage and have, be able to not only test as comprehensively as possible, but to be able to release as quickly as possible so that we can keep pace, so that QA, testing doesn't become that bottleneck for the organization or for that dev team. Same thing with pre-release. And then for feedback, you would use a cloud solution like Soft Labs for live test, bug reproduction on any platform. So that's, again, a key advantage. So what you're seeing here is really a necessity to have a cloud-based solution so that test automation can be implemented at that high level. So how do you actually apply this to your pipeline? Well, as we talked about before, if you have those teams, whether they're co-located or distributed, and those teams are going to have certain items from their dev plan, such as feature definition, test authoring, test-driven development, behavior-driven development, and so forth. And then from a code perspective, creating unit tests and also at that component test. So those local dev environments, they want to be able to take that code and then merge it into that shared delivery pipeline. So now you can go across those 4 phases of build, test, deploy, and operate, and basically implement that in a continuous improvement fashion. So with that, from the build, Soft Labs or having that cloud solution is going to help ensure that you have a stable build. And then you'll be able to verify the functionality during the testing phase, again, whether it's API, regression, performance testing, including front-end performance testing, which is very critical to understand a lot of those applications that are especially front-end heavy, especially those JavaScript applications. And then, of course, through deployment, make sure it's deployment ready, and then feedback. So you can see how all this relates to your application pipeline. Now, if we take it a step further, we talked about before how mobile plays a huge part of this. So we cannot forget that mobile is a mobile-first development type world, but it's not mobile only. So you want to look at it, how do you test across all these different platforms from using the tools at your disposal, whether it's mobile emulators and simulators or real devices, as well as those different cross-browser tests that you want to run, or even doing that headless testing within the cloud on these platforms. And with that, I will pass it on to Jayanthi to talk about the use case with Soft Labs and Aspire Systems.
Thank you, Clint. So here we going to look into an actual case study wherein we have successfully done a continuous testing along with the cloud testing implementation, which is Soft Lab, for one of the leading online assessment solution provider. So as you see from here, it has got a wide fragmentation to be tested, multiple browsers from both the Windows and the iOS systems, and also it has got to work in a response to the design in terms of mobiles and tablets from both the Android and iOS platforms. So the manual testing or kind of conventional testing, legacy testing was the one which was existing initially, and it was really impractical to cope up with the time to market, and the testing cycles were getting extended, and it was really consuming like around 40-50 days of manual effort if we have to test regress everything and then push a set of code to the release in the production. So here came the solution of continuous testing and further integration with SauceLab Cloud to cover the entire fragmentation of devices you see here. And these talking about the CI practices which we deployed here, as you see here, it's like we just bifurcated and then segregated the actual certification scope into 3 layers, which is like smoke, regression, and integration. So the smoke is a kind of a prime deciding factor or a kind of primer suite which actually decides whether the code which has got checked in is stable enough for the next level of deployment. So it's like 15 minutes, just a quick test which lasts in different platforms of 7 browsers and 7 devices in parallel. So any showstoppers we see here, we abort the execution, trigger an email, notify the respective audience who have to action on it, and then we just cut off the code movement to the next level in the pipeline. In case if it is true, then it moves seamless to the next level, the code gets promoted. Also, we just trigger the next set of scripts, which is called the regression suite, which does a deep dive in terms of testing. So as you see here, it again goes through 7 browsers in parallel, runs for around 8 hours, triggering parallel test in SauceLab Cloud. And once this is through, it gives us a next level of confidence, and then the code moves to the next level, and then we further run the integration suite. So it goes in a cyclic manner, wherein for each and every build, we we just segregate everything into kind of smoke, regression, and integration. So integration has got to do more with a kind of end-to-end test. So whenever modules are tested standalone and certified, here is a chance wherein we interlink all the modules and run them in one go so that the real-time business scenarios actually get tested here. And talking about the technical architecture, how this continuous testing was implemented with SauceLab Cloud, he started with the Aspire framework for test automation, which is AFTA, was integrated and residing in a kind of big bucket repository. And this repository was linked with SauceLab Cloud, and through a continuous integration listener like Jenkins, the Sauce on-demand plugin and WebDriver test matrix, we were able to configure the same set of automated test scripts across multiple browsers and then mobile devices. So which really made it a kind of flexible, reusable piece of code getting executed across multiple platforms in the SauceLab Cloud. And then through Sauce Connect, we were just able to run it in the SauceLab Cloud, trigger the scripts in SauceLab Cloud. And for the SauceLab had a kind of report publisher, so it gave us a kind of audit trail of whatever has happened during the real-time test execution. And also it captured videos of each and every test run during the runtime. And talking about the continuous integration workflow, how this build unit test, just one cut phase actually got promoted to the real production environment is the complete DevOps cycle you see here. Like people code and then they keep on pushing code in the development environment, and then it goes to a kind of version control, gets deployed and then a set of tests get triggered first. Once the test results are passed, then it gets promoted to the next level. So it's the first level is a kind of the quality gate check 1, wherein the build and unit test are verified, then the code is promoted to the QA environment, wherein we run the real-time full regression suite. So once the tests are passed, then the feed gets committed, and then the next level comes into picture, which is the UAT test environment, wherein the next set of scripts lined up here gets promoted. In case if there is a failure, then there is a push or a kind of fallback mechanism wherein the further stages of code promotions are arrested, and then the respective team gets to understand the logs, the technical failures from the logs, which is part of the framework, and as well as they take a look into the live demo, which is captured in the SauceLab Cloud, and then whatever is the corrective action required, the team start working on it very quickly. So it's a kind of unattended execution which gets automatically triggered through this kind of integration mechanism, so that any kind of code check-in whenever happens, the testing process gets started automatically, and also the results are notified automatically from this kind of an integrated setup. And once all the 3 quality gateways are through, it is then finally the code gets qualified for a production deployment. So here is where we just get to see the complete vision of the test coverage, which was literally achieved using this continuous testing and source lab integration. So Smoke, which had a widespread of 7 desktop and 7 devices, and then which was consuming around 12 hours before automation, we were just able to reduce it in 15 minutes through multiple threads, through parallel executions. And also the same is the case with regression and integration. So 180, 90, the percentage figures you see here is in terms of the test coverage. Certain test cases, they were parked outside automation because of some technical restrictions that we were not able to execute it in one go. Probably it needed a batch intervention, it needed a wait time. But the rest of it, we were just able to automate in no time, and the execution really helped us a lot when on-demand builds were happening every day with multiple teams keep adding up in the development end of it. This rigorous continuous integrated automation code integrated source lab was giving the prime confidence for code promotion to the production. And from the technology standpoint, the application was a web application with responsive web design and designed with REST APIs, and had to support with multiple Windows and mobile, tablet, iOS and Android platforms. And from the solutioning test automation continuous testing point of view, the solution primarily used here was Selenium WebDriver with Java scripting, and then with continuous integration using Jenkins, and cloud execution facilitated through Source Labs, which enabled cross-platform execution, cross-browser, multi-device execution, and headless testing with REST APIs. Even this calls were integrated with the GUI layers, so that while we were running the integrated test, there was a clear functional sync of the output delivered by the API calls, whether it's being picked up and whether it's being displayed in terms of the GUI layer as such. So this was a complete end-to-end test, and the ROI we realized out of this particular project. And while we get into the finer details of what was the turnaround time in terms of Smoke, regression and integration, whatever was happening for us to get for before pre and post automation, it was literally like less than 1/10 of the time. And also we were not planning explicitly to run the test automation. The environment was all set, so it is on demand, and whenever there is a code check-in, the process was pretty automatic. And with the team size of 12, we did not get into a greater mission of team expansion or anything to support newer functionalities. So with the same size, we were able to support, which is like the complete QA focus moved on into parallel streams of new functionality testing, and then also parallel automation and regression, integration, supporting the continuous testing and then continuous delivery in a DevOps mission. So this was just accomplished with an optimal team size by just bringing in this integrated solution of Aspire framework for test automation integrated with Source Lab Cloud. And the savings in terms of numbers is what you see in the tabular columns below. So whatever we had, like in terms of the duration, the initial development effort was something which we took to set up the framework and just bring in the solution, cement it, and then after that it became a complete reusable piece of code with a minimal maintenance effort. So this accomplishment, it stands out like, and it actually replaces the need for 100 physical VMs, which are actually required to run all these set of test cases and certify them for any code promotion or a kind of in terms of the release management. And also talking in terms of the numbers, I mean the cost involved with the procuring an infra, maintaining it and scaling it up or down, because there will be kind of major releases, minor releases and kind of patch deployments, depending on which the number of fragments that we test also varies. So having a kind of a cloud infra like Source Lab, which will really help us to scale up or down based on the number of platforms that really needs to be tested. So this is a kind of diversified testing requirements that we were able to accomplish by this kind of integration. So this is pretty much part of today's webinar, and I think we have accomplished it. So we got to discuss about, we actually started with how testing used to happen and what was the journey which test automation traveled through, and what is the current need or the hour in terms of getting into a shift left approach, moving on more from a kind of reactive to a proactive approach, increasing our testing by leaps and bounds, ensuring and quality is met at each and every point, and then bringing out a superior customer experience and fit for use. So in terms of the product and the application is all, and how we actually envision and then embed quality engineering in terms of a complete DevOps cycle is what we discussed for now.
Thank you, Jayanti. It's now time for the Q&A session. We have some questions from the audience. Let me read out the first one. What is the percentage of functional UI testing which is executed in pipeline? I heard functional UI testing should be minimal in pipeline. Thanks for this question. Jayanti, would you like to take this up?
Yeah, this is actually a real-time practical question. So as we were just looking into the previous case study as well, the number of regression cases we had there was actually 10,000. So prioritizing it as in terms of like priority, high priority, like priority 1, priority 2, priority 3, which is where we actually came down into and then converged to a suite of smoke testing, regression testing, and then further integrated testing. So what quantity of test actually needs to be tested for kind of major, minor and patch releases is where we will have to plan and bucket and then organize our test suites accordingly. So it's not just about a kind of percentage distribution. Here is where we actually look into the impacts, release planning of a particular release, and then really check what is the impacted area and what are the core areas to be tested. So having automated everything, it's completely in our decision to what has to be hooked up in the CI pipeline for to be tested automatically or to undergo the continuous testing at each and every point in time. And also it depends on the kind of stages of the pipeline, wherein we just have to check whether the code compilation is working fine, and whether it's kind of a development check, then probably we don't get into more of a functionality in depth, and then whether it moves on, whether we have to move to the next level and gain further levels of confidence is where we finally get into next stages like QA environment, and then next a pre-prod, which is a UAT environment, pre-production, and then finally a kind of production environment. So it is depending on our need. We just mix and match the test cases, organize them into test suites and trigger them across multiple environments and really gain the confidence whether the new set of code is working fine.
Thank you, Jayanti. I hope that question was answered. We'll move on to the next question. How do you implement continuous testing if you are testing mobile applications? Clint, would you like to take that up?
Yeah, sure. So if you're testing mobile applications, one of the things that you want to ensure is that you have a stable and reliable environment, and you really need to understand your cost as well. So in order to implement continuous testing, typically what we've recommended what we recommend for our customers is to use not only real devices, because you definitely should use real devices, but use emulators and or simulators for Android and iOS testing. And the reason you want to do this is because you want consistency and more control over that testing and be able to, and we talk about shifting testing as early in the software development pipeline as possible. By implementing emulators and simulators with the automation frameworks, you'll be able to have that level of consistency and less dependency on those devices. So what we typically recommend is a combination of all three, of real devices, emulators, and simulators, to be able to implement pretty much all of the things that you saw in the presentation today.
Thank you, Clint. Moving on to the next question. Which process catalyzes the DevOps mission? Jayanti, can you answer that?
Yeah, so this is the theme of the webinar we were discussing about. So it's about governing or getting into a more deep into a process of quality engineering, and then understanding which areas actually needs to undergo automation, and then adhering to a process of test automation all throughout the life cycle is which catalyzes the complete DevOps mission and helps us accomplish the complete DevOps cycle as such.
Thank you, Jayanti. The next question, is manual and exploratory testing still important for DevOps? Clint, would you like to answer that?
Sure. Yes, manual testing and manual testing and exploratory testing is definitely important with DevOps. Meaning that, of course, with DevOps, you want to achieve as much automation as possible, as early and often, but there are still various aspects that you want to be able to do. So there's going to be certain things that are, certain edge cases that you're going to have to test for. And it also helps supplement some of the things that aren't automated. So currently there's still a need for manual and exploratory testing. So it just depends on how it's going to be implemented and when it's going to be implemented throughout the continuous development life cycle. So making sure that automation is a must, and you must do test automation, but you want to be able to supplement or augment your testing with that exploratory testing from your subject matter experts, as well from a manual testing perspective. And especially if you're implementing mobile, most customers that we work with, they typically start off testing a lot of their applications manually on the various mobile devices or emulators and simulators. So there's definitely a need, and it's not going away anytime soon.
Thank you, Clint. So this brings us to the end of the webinar, and I would like to thank Clint and Jayanti for coming up with this presentation and sharing their knowledge on the need for quality engineering and how to enable continuous testing in a DevOps environment. I'm sure this session was useful for all. In case of any queries, please do email us and we'll be glad to assist you. Thank you once again on behalf of Source Labs and Aspire Systems for joining us. Have a great day.